So the next thing we're going to talk about here is we're going to explore some more intermediate operations in Java streams, including filter and flatMap. As we'll see, these are also stateless run to completion operations, unless, of course, there's a short circuit terminal operation. And it'll be interesting to see the discussion about filter, because at first glance, you might think filter can be a short circuit operation, but when we talk about its semantics, you'll see it has to be a run to completion operation. So we'll start with filter. So the intent of filter is to test a predicate against each element in an input stream and return an output stream that only contains elements that match that particular predicate. So as you can see, if you take a look at the kind of pseudocode here, you can have a filter and it takes in a Java functional interface called predicate. We've talked about predicate before, and predicate basically has a single test operation that returns true or false. It takes an element of type T and returns true and false, true or false. So as a consequence of the semantics of filter, the number of elements in the output stream may very well be less than the number of elements in the input stream, if there's some that don't match the predicate. Now, if they all match the predicate, then it'll be equal. And of course, it'll never be greater than the number of elements in the input stream. So it's either going to be less than or equal to. The way we're going to use it here in our simple search stream program is we're going to use the filter intermediate operation in conjunction with a method reference in order to be able to only allow elements to continue through if they happen to be not empty. So if they're not empty, we let them through. If they're empty, then we go ahead and we filter them out. Unlike map, which could change the type and or the value of the elements that are flowing through the stream, filter can't change the type or value. It can only decide to let the element go through or not. So it's always going to come back as the same value if it didn't get filtered out. You can see here how we can combine this with the other various intermediate and terminal operations in the stream using the fluent interface style, as always, in order to be able to build a pipeline that makes this type of transformation. So filter is very straightforward, turns out to be very useful, and you'll get a chance to apply it in some of the programming assignments that we'll do. Let's now talk about a more interesting intermediate operation called the flatMap operation. And you'll see that what this operation is defined to do is it returns a stream that replaces each element of the stream with the contents of a stream that is produced by applying the mapping function to each element. Well, when you read that particular description, the first thing you might say is, gosh, that sounds pretty much identical to map. How does flatMap differ from map? And it turns out that there's actually some really important differences, but I agree at first glance it does sound very similar. So here's one way that map and flatMap differ. So remember, map will always return the same number of elements in the input stream as the output stream, unless an exception occurs or there's a terminal operation that's short-circuiting. Conversely, flatMap can return the same number of elements, but more commonly, it'll return either less than or greater number of elements in the output stream. So it basically gives you the full kit and caboodle of being able to either have the same number, less elements, or more elements. And most commonly, when you use it, you typically get more elements in the output stream, although we'll see even in this example here that it's possible to get less elements as well. We'll talk about that too. So the way you can think about flatMap and where it gets its name is if you have a stream of structured data elements, like you might have a stream of lists of elements of type T. Let's say we have a stream of lists of strings, just for example. When you flatMap that stream of lists of strings, what you end up with is a stream of strings. So it'll basically go through and it'll flatten out the structured data, converting it from lists of strings into strings, or a stream of lists of strings will turn into a stream of strings. So you can kind of think of it like the image I always have in my mind is a steamroller runs over the data and it flattens it out. So now you get rid of the structure and just have the elements put together. And you see this is a very, very useful thing to do. Like map, flatMap can also transform the elements it processes. And to some extent, like filter, it can also get rid of elements. So for example, if you have a stream of empty lists, or if you have a stream of lists where some are empty and some are not empty, then flatMap can be used to get rid of the empty lists, because of course there's nothing in them. So when it flattens them out, it comes back with the null list, and the null list is then ignored. So that's how you can end up with fewer elements than you had gotten as input. If everything that comes into flatMap is a structured container, a structured collection with nothing in it, you'll end up with less elements coming out when you are done applying the flatMap map operation. Here's a very simple example that illustrates this point. You can find this in my EX12 folder in my GitHub repository. What this does is it bakes a bunch of different lists of strings, and each list of strings had a subset of the character names in Hamlet, just for kicks. And then we went ahead and we made a stream of lists. So we say stream.of L1, L2, L3, et cetera, up to Ln. And then we flat map those lists, and we end up with just a stream of strings corresponding to the flattened names in Hamlet. So this turns out to be a very, very powerful operation, and you'll get a chance to apply it throughout the various programming assignments that work with Java streams. So that's the end of filter and flatMap. At this point, I think you actually do pretty much have enough information to do programming assignment 1 or 2A. So programming assignment 2A, as you'll see, is based on map and filter and flatMap and so on. And so you could probably get most of it done. You don't have to start right away, but it wouldn't be a bad thing to take a look and see how you could convert the loops and the if statements to basically map and filter. So those are typically the way that's going to be done.